Hi, this is John Lindenball of John Lindenball Tutoring, and this is Breaking Math, Part 3, Ratios and Other Math, Saul Style. And remember, if you like this video, please hit that like button and subscribe and share this with other people. That's a great way to help me make more videos. Let's meet our new friend, Gene Tankovic. Gene manages a food court Cinnabon at a shopping mall in Omaha, Nebraska. We're going to see Gene in just a second here. Here's Gene right now. Notice that Gene looks an awful lot like our favorite attorney, Saul Goodman. Maybe it's Saul doing some undercover research. Cinnamon swirl, ratios and proportions Saul style. Gene manages a Cinnabon in Omaha, Nebraska. The recipe for the famous cinnamon buns calls for 3 cups of flour, 1 cup of sugar, and half a cup of cinnamon to make 12 Cinnabon rolls. How many cups of flour, sugar, and water does Gene need to make 96 Cinnabon rolls? Well, first we know that 96 over 12 is equal to 8, so to keep every ingredient in the increased recipe proportional, we must multiply each amount by 8. So we're going to need the 3 cups of flour. 3 cups times 8 is equal to 24 cups of flour. Then we need 1 cup of sugar, so 1 cup times 8 is 8 cups of sugar. And 1/2 cup of cinnamon times 8 is, of course, going to equal 4 cups of cinnamon. So there's the answer.
Hey, I'm a civilian. I'm not your lawyer anymore. A month from now, best case scenario, I'm managing a Cinnabon in Omaha.
You're still part of this, whether you...
Baby blue. Walt and Jesse need 2.5 kilograms of sugar and 100 milliliters of blue dye to make 3 kilograms of their special blue rock candy. How much sugar do they need to make 100 kilograms of the candy? Baby blue continued. Make a proportion. Well, so we can say we need 100 kilograms of the candy per batch, and this is 3 kilograms per batch. So to make a 100 kilogram batch, we're going to have to set up this proportion. So 100 over 3 equals S, where S is going to be the number of kilograms of sugar, and we know we need 2.5 kilograms of sugar per 3 kilogram batch. Then we just solve for S. So we just multiply 2.5 kilograms of sugar times this, so you end up with 100 over 3, comes from here, the kilogram per batch units cancel out, times 2.5, which is equal to 833.33, or 833 and a third. Question 3, same as number 2, but how much dye did they need to add to make 100 kilograms of the candy? Since we know the ratio is 100 over 3, or we just multiply 100 over 3, times 100 milliliters, which becomes 10,000 milliliters over 3, which becomes 3,333. So basically, 33.33, and then the 3's just keep going on after the decimal point, milliliters. How much blue dye is that in liters? They could ask you to change the unit in an SAT or ACT problem. So we have 3,333, I should say. So 3,333.33333 milliliters times 1 liter per 1,000 milliliters. So the milliliters cancel out. We divide 3,333.33 by 1,000, and we get 3.3333333, repeating decimal, or again, 3 and a third liters. They could ask you that on the test. Under pressure. Senor Salamanca has to take 3 pills per day for his high blood pressure. How many pills does he have to take for a year? This one's really easy. You just make the fractions and multiply them together as we did in the previous problems. This is often called dimensional analysis. You've done this before if you've had any chemistry or physics classes. So we're going to go 3 pills over 1 day. That'd be 3 pills per day. Per means divide. Multiply by 365 days for 1 year, and 365 days per, so we're dividing by 1 year. This is our conversion factor. And the way that you know you've done it right is the units you don't want cancel each other out. So day and days, they're going to cancel each other out. Great, so we get pills per year. That's exactly what we need. So 3 times 365 is 1095. So we can go and use our handy Windows calculator. Obviously, you won't have this when you take the test, but I can just use the the calculator on Windows here. So 3 times 365 is 1095. Okay, if it's a leap year, then it would be 366 times 3, which is 1098 pills per year. So here we go. Under pressure. Lucky Candy Bucket. Gus likes to play a little game with his Los Pollos Hermanos restaurant managers. For every 50 buckets of frying chicken batter, 1 bucket is marked with a star that can be seen only under ultraviolet light. That bucket has a special prize, Walt and Jesse's candy, in it. If a manager opens a barrel at random to search for the prize because he lost or broke his UV light, what is the probability the bucket has the special prize? To find the probability of the event, use this formula. P is equal to the number of desired outcomes, what you're looking for, so in this case, finding the barrel that has the ultraviolet star on the lid, and the possible outcomes, which is just finding a barrel of fry batter, a bucket of fry batter. Anyway, so let's move on. Lucky Candy Bucket. P is equal to the number of desired outcomes over the number of possible outcomes. Since we know there's 1 star bucket, and then there's going to be 50 non-star buckets, plus the 1 star bucket, the probability is 1, the desired star bucket, over 51, all the buckets. So the probability of the manager selecting a lucky star candy bucket is 1 over 51, or approximately 0.0196, which is 1.96%. And it's always a good idea to check this using your calculator. If you are allowed to use your calculator on the calculator section, use your calculator to do all your math, because one time I did this, and even though I knew, okay, 1 in 50 is 2%, for some reason my brain is saying, oh, okay, it's 19.6%. It's not. If you go 1 over 51, you get 0.019, and then multiplied it by 100, and it's 1.96%. For some reason I was like, why isn't it 19.6? So that's why you should always check it with your calculator, because you don't want to not get points because you made a stupid arithmetic error like I did the first time that I did this problem. So anyway, you could grid in 1 over 51 and then avoid that problem, or 0.02 if this were a gridded answer, if they were just asking for the fraction. And if they wanted the percentage, then you would probably put 1.96, etc. in a grid in, depending on what they asked. So let's go. Saul calls, counting and probability. Saul manages to buy a lot of cell phones, all the phones with numbers area code 505, that's Albuquerque, New Mexico. 555, yes, the standard fake phone exchange. XXXX, where X represents a digit. So A, how many cell phones were in the lot, that is the batch of cell phones? Since the last 4 digits of a phone number can be any 4 digits, each 0 through 9, each 4-digit suffix can be 0xxx, 1xxx, 2xxx, 9xxx, then x0xx, through 09xx, and so on, or should be x09xx, etc. So anyway, made a little typo here, 09xxx, but you know what I mean. Each one of these x's can be a digit 0 through 9, so there are 10 possible digits. So the number of combinations is 10 times 10 times 10 times 10. So we can quickly multiply it out. 10 times 10 is 100, times another 10 is 1,000, times another 10 is 10,000. Okay, that's again something you should probably just do on your calculator really quickly, because it's really easy to just look at it and go, oh, okay, well 1,000 would be 1 followed by 3 zeros, so, oh, okay, there's 1,000. No, there are 10,000, because each of these can be 0 through 9, so there would not just be 1,000, everything would be 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. So, Saul bought 10,000 phones. I certainly hope he got a volume discount. He would need it for that many phones. And Saul calls continued. All right, part B. Saul decides to keep the phone with number 505-555 Saul for himself. If an autodialer automatic dialing machine used for mass messages and spam calls 505-555, then 4 random digits, what is the chance the autodialer will call Saul? Well, we know that there are 10,000 combinations for the last 4 digits of a North American telephone number. So, as we saw before, to find the probability of an event, use this formula. P is going to be equal to the number of desired outcomes over the number of possible outcomes, which is going to be equal to 1 over 10,000. So it's a 1 in 10,000 chance. And if you want to see what that looks like as a decimal, we can certainly do that. We go 1 over 10,000, so that's 0.00001. If we want to express it as a percentage, we multiply it by 100. So that's going to be 0.01%. All right, let's move on. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I also don't have anywhere near 1,000 subscribers. For the same reasons, you're not only welcome, but encouraged to share links to this video, put in playlists, etc.
I'd appreciate your input.
I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or things that are off topic, spammers, disturbed people, whatever. Please don't post in my comments if you're a spammer. And if you're a disturbed person, please don't post in my comments and please get help. Contact me. Cell phone 415-623-4251. Email john@johnlinnebaugh.com. Mail 1859 Powell Street, number 109, San Francisco, California 94133. Thanks for watching, and there's a little more information following this. Contact me. All right, you can contact me on Facebook at facebook.com/Linnebaugh Tutoring. Instagram.com/john.linnebaugh.tutoring. Phone number, this is my office phone, 415-986-7355. Email john@johnlinnebaugh.com. Website, www.johnlinnebaugh.com. Testpreparation.locals.com is another site where you can find a lot of this content. Legal disclaimer. I have no idea what the formulas or specifications are for any food or other products mentioned in this video and don't own any copyright or trademark to those products. So any use of copyrighted material falls under the fair use exceptions to the Copyright Act of 1976, 17 United States Code, Section 107. See also Campbell versus Acuff Rose Music from 1994, 510, United States Reports, 569. So please don't sue me, Cinnabon, Better Call Saul, Breaking Bad, or any other owners of trademarks that I have referenced in this video. All right, hope you have a great sense of humor and a great day. Thanks. Bye.